Okay, Assalamualaikum and hi to Dr. Shafiqa. My name is Anisha Zana binti Adnan, S51774. We from Group 7 will present a case study on fuel cell in Japan. So these are the members of the group, which are Azim Najimi, Imi, myself, and Fadila Nurizati and Nuri Yasmin. So this presentation will include the introduction, advantages and disadvantages, methodology that will include the design, method, calculations and installation, applications of fuel cells, conclusions, and lastly the references. So I will start with the introduction. What is fuel cell? Fuel cells are the electrochemical cells that consist of two electrodes, which are anode and cathode, and it also has an electrolyte that will convert the chemical energy, which is hydrogen, into an electrical energy, and the only product is water. So the chemical equation can be written as shown in the slide, where oxygen plus hydrogen will produce H2O. So moving on to the history of fuel cell. In 1839, fuel cell was first discovered by Sir William Grove when he found out that electricity can be generated by reversing the electrolysis of water. Then in 1932, Francis Bacon has successfully developed the first fuel cell device by using oxygen, hydrogen, alkaline electrolytes and nickel electrodes. Then this revolution is followed by NASA when they develop electrical generator for space program. Then for the types of fuel cell, the fuel cells are classified by the types of electrolytes that they use, and these are the examples of types of fuel cell, which are alkaline fuel cell, phosphoric acid, solid oxide, molten carbonate, and proton exchange membrane fuel cell. And there are many other more types of fuel cell that already in the market. So for fuel cell in Japan, Japan is one of the country that actively developing the hydrogen energy. As for now, Japan is in the third wave of hydrogen, where it starts around 2015, and the first wave was around 1990s, and the second wave was during early 20s. And so in 1990s, Japan have limited domestic energy source, so they made a deliberate choice to develop a hydrogen-based society. In 2000s, the Japanese government and industries give more focus on popularizing and promoting fuel cell vehicles with a view to improve the effectiveness of hydrogen refueling stations. And in 2011, Japan was affected by the Great East Japan earthquake and the nuclear accident. So this accelerated the government to realize the importance of hydrogen-based society. So the government announced the Fourth Strategic Energy Plan, and in the same year, the government compiled the strategic roadmap for hydrogen and fuel cells. And in 2015, is known as the first year of hydrogen in Japan.
Assalamualaikum warahmatullahi wabarakatuh. My name is Simir Anisha binti Zaki. My matrix number is S50457. Can I explain about the advantages of fuel cells? The advantages of fuel cells, it can give a protection for climate and energy security by being a leading role in meeting national goals of clean air and can reduce carbon dioxide emissions. Next, it can obtain 80% efficiency compared to the traditional resource due to not affected by limitations derived from the Carnot thermic cycle. And it can produce electricity without combustion with low vibration, noise, and low maintenance required. Next, source of hydrogen fuel are everywhere, as example landfill gas, biomass, ethanol, methanol, natural gas, propane. And lastly, low maintenance because inside the site can be located and substitute damaged or multifunctioning cells. The disadvantages of fuel cells. The cost for stationary electric generation of fuel cells is too high and not suitable for the substitution of the technologies based on fossil fuels. Next is, as hydrogen is the main fuel for fuel cell technologies, it is expensive and not easy for production and distribution. Next, the disadvantages of this fuel cell is it is limited to use for low temperature fuel cells in car market due to the difficulties in confining a suitable quantity of hydrogen. There are a few types of fuel cells, which are solid oxide, molten carbonate, and phosphoric acid fuel cells. The advantages of SOFC is has high efficiency, but the disadvantages of SOFC is it is high cost. Next, CFC has high efficiency, but the carbon monoxide of the product is poisoning, and PFC is commercially available, but it is limited lifetime. Then the alkaline fuel cell is ineffective materials, but it lack of carbon monoxide tolerance. Then DMFC can reduce system complexity, such as fuel reforming, but the DMFC required anode kinetics, crossover, complex stack structure, and noble catalyst. Lastly, proton exchange membrane fuel cell has high power densities but lack of carbon monoxide tolerance.
So for fuel cell design, we will discuss about the fuel cell stacks. So as you can see in the picture, one cell produces a limited output, so it is necessary to stack the cells together to reach a higher electrical voltage. And a stack of this cell is called as fuel cell stacks, or they also called as fuel cell battery. And in principle, the performance of fuel cell system is high and it can outperform the combustion engines. So for parts of fuel cells, there are four parts of fuel cells, which are anode, cathode, electrolyte, and catalyst. So anode is the negative pole of the fuel cell. It conducts the electrons that are freed from the hydrogen molecules so that they can be used in an external circuit. Cathode is the positive pole of the fuel cell. The H channels will distribute oxygen to the surface of the catalyst, and it conducts the electron back from the external circuit to the catalyst. Then it will recombine with the hydrogen ions and oxygen to form water. Then for the electrolyte is the proton exchange membrane, and it only conducts positively charged ions, and the membrane will block the electrons. Lastly is the catalyst. The commonly used catalyst is the platinum powder that is very thinly coated onto a carbon paper cloth, and it has a special material where it will facilitate the reaction of oxygen and hydrogen.
Now I'm going to explain about the fuel cell operation in Japan. So, same as other fuel cells, the methods are generally the same. The fuel cell consists of two electrodes, which the positive one known as cathode and the negative one known as anode. The electrodes both is sandwiched by an electrolyte. The fuel used is hydrogen fed to the cathode and the air is fed to the anode. The function of catalyst is to separate hydrogen molecules into protons and electrons, which then take different paths to the cathode. Then the electrons go through an external circuit, which then creating a flow of electricity. The protons then reunited with oxygen that pass through the electrolyte to the cathode, and the electrons go to produce heat and water.
The calculations that may involve in fuel cells, there are current density, volt per cells, power per cell, number of cells needed, total current, total voltage, and total power. For current density, for the formula is J equal to IFC divided by area cell, and the volts per cell depends on the table of polarization curve between current density and volts per cell. Power per cell equal to current density multiplied by active area size and multiplied by volts per cell. And number of cells needed can be calculated by design power divided with power per cell. Then the current is active area multiplied by the current density. The total voltage can be get by multiplying the volt per cell and number of cells. Lastly, the total power can be get by multiplying the total current and total volt.
Assalamualaikum. My name is Azim, student number S52305. Will present about the installation under the method. So to start using the fuel cell, a fuel cell generator must be applied. The fuel cell generator is consists of a proton exchange membranes PEM fuel cell with a 4 basic subsystem, which including the airflow subsystem, the cooling subsystem, the power conditioning subsystem, and the hydrogen supply subsystem. So the fuel cell stack is made up of a cell that carry 2 composite plates and a membrane that made from polymer, which is 4 subsystem, which the help of 4 subsystem. The first one is the airflow subsystem. It is to supply the filtered chilled air into the fuel cell stack. Consists of cathode air filter, the cathode air blower, and the humidifier. The cathode air filter is to remove explosive gas and contamination from the air using chemical absorption. The cathode air blower is used to suck the air into the fuel stack. The humidifier is to transfer the heat and humidity to the inlet air stream from the fuel cell stack. So the second one is the cooling subsystem. It is to provide coolant pump into circulate in the fuel cell to remove the heat generated through a turbofan radiator assembly. So the third one is the power conditioning subsystem. This subsystem provides the proper interlinking between the stack power and the external load when the high power demand on the external load, the stack power is boosted and the battery discharged to add extra power both in DC bus. When the low power demand on external load, the battery is charged by the power converter using extra stack power. So the last one is the hydrogen supply subsystem. It is to supply the hydrogen fuel into the fuel cell to generate the electricity power.
Assalamualaikum. My name is Fadila Nur Izzati binti Daud, S51553. Today I will present about applications of fuel cell in Japan. First, Toyota Motor Corporation. Toyota Motor Corporation is leading the Japanese hydrogen mobility market, launching Japan's first fuel cell truck, forklift, and bus. Toyota has impact fuel cell vehicle production both in Japan and abroad. This is the 8 updated versions of the large FCHV Bus 2 no-step bus fitted with a hybrid fuel cell system produced jointly with Hino Motors. Second, Toshiba. Toshiba is developing direct methanol fuel cells, DMFC, subcategory proton exchange membrane fuel cells, PEMs, in which methanol is used as fuel. The developing of DMFC is for notebook PCs, cell phones, and portable data devices. This is the Toshiba notebook PC using DMFC. Lastly, Fuji Electric Advanced Technology. Since 2000, the company has mounted 15,100 kilowatt phosphoric acid fuel cells, PAFCs, continuing at an average rate of 2 or 3 each year. With an efficiency of 40% and overall efficiency of 87%, Fuji's PAFCs are more efficient than the same class commercial cogeneration system. As such, the organization seems to have achieved its technological objective in terms of power efficiency. This is the PAFC's power generator that used in hospitals, hotels, and others to sewage treatment plants for disaster prevention.
For the conclusion, basically the fuel cells were made to replace the existing power generator, or at least to give the new development in power generating. The usage of battery gives the DC power is a power that will run out, while the fuel cell will produce the electricity continuously if the fuel, which is the hydrogen and the oxygen, is supplied, and it will not give any problem to the society, which is the main problem is the pollution. The hydrogen only produce the waste product of water and carbon dioxide. It is stated that the car, the combustion gas from the car can be reduced up to 250 cars a year, which is basically a couple of thousand pounds of carbon monoxide, and then replaced with the hydrogen fuel cell that can make a difference in the problem of the pollution. So as for the current trend, is a company in Japan, Fuji Electric, is producing 101 power generator cells, fuel cell stack to produce about 14,000 kilowatt of power each year. That's all from us. Thank you very much.